the third part of second degree equations. Today I am discussing problems in page number 86, that is second exercise in your textbook. Look at the first question. 1 added to the product of two consecutive even numbers gives 289. What are the numbers? You know, consecutive even numbers and consecutive odd numbers differ by 2. So I took the two even numbers to be x and x plus 2. Okay, now use the condition. 1 added to the product of two consecutive even numbers. So what we are doing? We are going to add 1 to the product of two consecutive even numbers, and we are given the product is equal to 289. In the next step, we can multiply x with x. We get x square plus x into 2 gives you 2x plus 1 is equal to 289. Now, x square plus 2x plus 1 is nothing but the expansion of x plus 1 the whole square. This I have explained clearly in the second video. Please watch. This is equal to 289 is nothing but 17 square. Now you got square on both sides. So what we have to do? Let us take square root on both sides. Taking square root on both sides, you get x plus 1 is equal to 17, or otherwise x is equal to 17 minus 1, which is equal to 16. So the numbers are, we can say the two even numbers are 16 and the next even number 16 plus 2, 18. Second question. 9 added to the product of two consecutive multiples of 6 gives 729. What are the numbers? So we can take the consecutive multiples of 6 to be x and x plus 6. Do you understand? Now use the condition. 9 is added to the product. So we have to write the product of these two numbers gives you x into x plus 6. To this we are adding 9. By adding 9 you are getting 729. Now let us expand x into x. We get x square. X into 6 gives you 6x plus 9 is equal to 729. Let me write one more step for you to get a clear idea. X square I am writing as x square itself. 9 is nothing but 3 square. And what about this 6? 6 is nothing but 2 into 3 into x. This is equal to 729 is the square of 27. So we can write it as 27 square. Now by looking at this, you can very well understand this is the expansion of a square plus 2ab plus b square, where a and b values are x and 3. So we can write this as x plus 3 whole square is equal to 27 square. Then as we did in the previous problem, you have to take square root on both sides. So taking square root, we get x plus 3 is equal to 27. So what is x? X is equal to 27 minus 3, which gives you 24. So the numbers are x. X is 24 and the next number is 24 plus 6, which gives you 30. So the numbers are 24, 30. Look at the third question. How many terms of the arithmetic sequence 5, 7, 9, etc. must be added to get 140? We have studied sum of n terms, which is represented as Sn. Sum of n terms of an arithmetic sequence is got using our formula n by 2 into x1 plus xn, where x1 denotes the first term 5 and xn denotes the nth term. So to substitute in the formula, first of all we have to find out the nth term. So nth term of an arithmetic sequence is got using nd plus f minus d. Let us substitute difference and first term in this formula. So we get n. What is the difference here? 7 minus 5 gives you 2, plus first term is 5 minus difference is 2, or otherwise we write it as 2n plus 3. Now x1, that is the first term, is equal to 5. Let us substitute these two values in our formula for sum. So we can write n by 2 into first term x1 is 5 plus nth term 2n plus 3 is equal to, must be added to get 140. So we can equate this to 140. Is it clear? Next step, n by 2 into, we can write term with n first. So you get 2n plus 5 plus 3 gives you 8 is equal to 140. In our next step, we can take a 2 commonly outside. So we get n by 2 into, if you take 2 outside, what remains here? N will remain and 4 also will remain inside the bracket. This is equal to 140. Now let us cancel 2 with 2. Now what do you get? N into n is equal to n square plus 4 into n is equal to 4n is equal to 140. Now here we are going to use our method of completing square. We are given n square plus 4n. Now what is to be added to make n square plus 4n a perfect square? We have to add the square of half of 4. That is 4 by 2 gives you 2. So 2 square must be added on both sides. So by adding 2 square, we get n square plus 4n plus 4 is equal to 140 added to 4. Now n square plus 4n plus 4 is nothing but the expansion of n plus 2 whole square. So we got n plus 2 whole square is equal to 140 plus 4 gives you 144, or otherwise it is the square of 12. So we can write n plus 2 whole square is equal to 12 square. Now taking root on both sides, you get n plus 2 is equal to 12, or n is equal to 12 minus 2, which gives you 10. So we got n is equal to 10. So what did you understand here, children? How many terms are added? 10 terms of this arithmetic sequence should be added so as to get 140. Look at the fourth question, children. 16 added to the sum of the first few terms of the arithmetic sequence 9, 11, 13, etc. gave 256. How many terms were added? We are given 16 is added to the first few terms of 9, 11, 13, etc. So to find the number of terms added, let us find the nth term. So we can write nth term of an arithmetic sequence to be equal to nd plus f minus d. Let us substitute first term and difference. This is equal to 11 minus 9 gives you 2. So our difference is 2. So you get 2n plus first term 9 minus common difference is 2. So we got 2n plus 7. Now we are given 16 is added to the sum of first few terms. So let us use our formula sum of terms. Just now we saw sum of terms Sn is equal to n by 2 into first term plus nth term. Let me write the formula. First term plus nth term. Now let us substitute all the values. N by 2 into first term is 9 for us plus nth term we got it as 2n plus 7 is equal to, we are given the sum is equal to 256. So we can write plus 16 is equal to 256. Is it clear? Sum of first few terms added to 16 gives you 256. So first of all I wrote sum of terms which is n by 2 into first term plus nth term, to which we have to add 16 which is equal to 256. Now let us simplify the first part. We get n by 2 into 2n plus 9 plus 7 gives you 16. Added to 16 is equal to 256. Now as we did in the previous problem, take 2 commonly outside. So you get n by 2. 2 is taken outside. You get n plus 8 because 2 into n, 2n. 2 into 8 gives you 16. Now cancel 2 with 2. Plus 16 is equal to 256. Now let us expand. N into n gives you n square plus 8 into n gives you 8n plus 16 is equal to 256. Now you can understand n square plus 8n plus 16 is the expansion of n plus 4 the whole square, because n plus 4 the whole square gives you n square, first term. 2 into n into 4, that is your second term. N square, 4 square is 16. We got the third term. This is equal to 256 is nothing but 16 square. Now take root on both sides. Then what will you get? By taking root on both sides, you get n plus 4 is equal to 16, or otherwise n is equal to 16 minus 4, which is equal to 12. So the question, how many terms were added? We have to say 12 terms of the arithmetic sequences are added to 16 to get 256. Hope the idea is clear to you, children. More problems we will discuss in our next class. Thank you.